way. Convert the polar coordinate -5, 5 pi over 3 to Cartesian coordinates. And the Cartesian just means your xy coordinates. Okay. Now we know these are polar coordinates. So -5 and 5 pi over 3 polar coordinates. That means that this is your r and this is your theta. Because remember, your polar coordinates are just r theta. And you literally just plug them right into those two formulas. X equals r cosine of theta, and y equals r sine of theta. Okay. So that means x is going to equal -5 times cosine of 5 pi over 3, and y is going to equal -5 times sine of 5 pi over 3. Okay. So that means your x will be -5. Cosine of 5 pi over 3 is 1/2. And y is going to equal -5 times sine of 5 pi over 3 is negative square root of 3 over 2. Okay. And then from there, you just simplify it. Okay, so you have -5 over 2. And y, negative and negative is positive. So that would be y is equal to 5 square root of 3 over 2. So your xy coordinates just equal -5 over 2 and 5 square root of 3 over 2. So once you plug them in, you're pretty much done with converting them to Cartesian coordinates, or just your x and y. All right, so any questions on that one? All right. Okay, so what if we wanted to convert the Cartesian coordinate? Remember, Cartesian is just your xy. So it's xy equals square root of 3, 1 to polar coordinates. Okay. So really, we just want to find our comma theta. Okay. Remember that r is equal to the square root of x squared plus y squared. Okay, remember, this is your x, and that's your y. So that's just going to equal the square root of 3 squared plus 1 squared, which is equal to the square root of 3 plus 1, which is just square root of 4. So we know that your radius is going to equal 2. All right, so now we just have to find our theta. We know tangent of theta is y over x, which means that theta is tangent inverse of y over x. Okay, so theta is the tangent inverse of y, which is 1, over x, which is square root of 3. Or if we wanted to, we could rationalize the denominator. Remember, 1 over square root of 3, if you multiply it by square root of 3 over square root of 3, is square root of 3 over 3. So theta equals tangent inverse of square root of 3 over 3. Okay. So this is true when theta is equal to pi over 6. Okay. So that means our theta is equal to 2 pi over 6 as your answer. Okay. So you're still just plugging it in. It's just with the tangent inverse, it gets a little trickier. All right, any questions on that one? All right, I'm going to do another example here. Oops. So, say for example, say if we wanted to convert the Cartesian coordinates xy equals 0, -9 to polar coordinates. Okay. Now, whenever your x or your y is a 0, you have kind of a shortcut that you can make. Okay, so let's say just to visualize it, you have your x and you have your y. Let's say this is our 0, -9. X is 0, y is -9. Okay. So if our x is equal to 0, we really don't have that to worry about. But if you look at it this way, the distance from the center to that point is 9. So that means your radius would have to equal 9. From the origin to the point. And also, if you remember, this is pi over 2, pi, 3 pi over 2, and a full circle is 2 pi. Since you're on the y-axis, your theta is equal to 3 pi over 2. Uh-oh. Okay, so without even calculating anything on this one, your r theta is equal to 9 3 power 2. Okay. That only works when either your x or your y is 0. So it has to be either on the x-axis or y-axis. Okay, so if you had, let's say, xy is equal to, say, -4 0. If you drew a quick graph, that's your x, that's your y, and this is the point -4 0, then the distance from the center to this point will be 4. And your theta would be pi, since it's on the negative x-axis. Oh, clean that up a little. Okay, so your r theta is equal to 4 pi. Okay. So you know if your point was up here, it would be however far it is from the origin, and your theta would be pi over 2. Does that make sense? Okay. So it's just one of those shortcuts you can kind of look out for. All right. Any questions on that one? All right. So we will stop there.